A year after the research vessel Holo Holo vanished between the Hawaiian Islands, another ship stopped over a point in the Alenuihaha Channel and sent a coded acoustic signal into the water. The signal descended through more than a mile of ocean. Then something answered from below. The response did not come from the missing vessel itself. It came from underwater instruments of the same type carried aboard Holo Holo. Investigators treated the replies as the strongest physical evidence they had found. The ship had left Honolulu with 10 people on board and had never sent a distress call. No survivor had been found. No confirmed wreckage had been recovered. Yet far beneath the surface, near a location the vessel was never supposed to reach, its scientific equipment appeared to respond. That discovery changed the central question. Holo Holo was no longer simply a ship that had failed to arrive. It was a ship believed to be resting about 7,200 feet below the Pacific, roughly 28 miles south of Maui and northwest of its intended research site. But the acoustic signals could not explain what happened on the surface. How did a working research vessel disappear so quickly that nobody aboard transmitted a warning? The story began on Oahu on Saturday, December 9, 1978. At about 2:37 in the afternoon, Holo Holo departed Honolulu Harbor. Court records later described it as a 90-foot Alaskan power scow that had been converted first into a yacht and then into a research vessel. Its latest assignment connected several institutions. The Research Corporation of the University of Hawaii had chartered it for work associated with the University of Hawaii, the University of California, and a federal Department of Energy program. The project involved ocean thermal energy conversion, usually shortened to OTEC. The basic idea is to use the temperature difference between warm surface water and cold deep ocean water to produce energy. Hawaii, surrounded by deep tropical water, offered a natural place to study the concept. The Holo Holo voyage was part of a larger research effort near the west coast of the island of Hawaii, at a site about 17 nautical miles west of Kawaihae. This was not meant to be an open-ended expedition into unknown waters. It was the second of 6 planned 6-day voyages. The schedule called for Holo Holo to reach Kawaihae Harbor around daybreak on Monday, December 11th. 2 additional scientists were expected to meet the vessel there and board for the next phase of work. 10 people sailed from Honolulu. The vessel's owner, a licensed master of research vessels, a hydraulic mechanic, and 7 scientists connected to the project. Among the University of Hawaii researchers were Chief Scientist Gary Niemeyer, Michael Allen, and Robert Harvey. Decades later, colleagues still remembered them as dedicated scientists who cared deeply about their work and the sea. They were not anonymous figures inside an accident report. They were members of a research community, expected back in laboratories, offices, classrooms, and homes. Shortly after departure, Holo Holo was reportedly seen off Waikiki. That was the last confirmed sighting cited by the Coast Guard investigation. From there, the expected route led southeast from Oahu, through the channels between the islands, and toward the west side of Hawaii Island. The route matters because the waters between Maui and Hawaii can be demanding. The Alenuihaha Channel funnels strong trade winds between the high mountains of the 2 islands. Conditions there can change the motion of a vessel from manageable to punishing. The official reconstruction did not claim to know every wave Holo Holo encountered, but investigators concluded that the ship likely entered much rougher water than had been forecast. No routine radio report established the vessel's progress. No distress message described a mechanical problem, flooding, or a change of course. No confirmed voice from Holo Holo was heard after it left Oahu. This silence would become one of the most important parts of the case, because it left investigators without a final position, a final weather observation, or a final account from anyone aboard. Monday morning arrived at Kawaihae. The two scientists waiting to rendezvous with Holo Holo did not see the vessel enter the harbor. At first, a late arrival did not reveal what had happened. A delay at sea can have many causes, but as the hours passed without contact, uncertainty became alarm. The Coast Guard was notified on December 12th, one day after the scheduled arrival. A major search began. Aircraft and vessels from the Coast Guard Auxiliary, Navy, Air Force, Civil Air Patrol, the University of Hawaii, and others examined a vast area of the Pacific. A later federal court record stated that the effort covered approximately 377,000 square miles and included more than 520 flight hours. For Air Force U, 2 reconnaissance flights were also used. Searchers were looking for anything that could narrow the ocean. A radio signal, a life raft, debris, fuel, scientific equipment, or a person in the water. But the sea offered almost no confirmed evidence. The active search continued for 10 days without finding the vessel or anyone aboard. On December 17th, a commercial fisherman found a current meter box about 6 miles from the southwestern coast of Hawaii Island and roughly 50 nautical miles south of the research site. It was thought to have come from Holo Holo, but one object could not reveal the ship's path or the exact place it was lost. Ocean currents can carry floating material far from its source. The discovery raised possibilities without settling them. The search ended with a painful contradiction. 10 people had departed on a scheduled scientific voyage through a heavily studied island chain. The vessel had equipment, a destination, and people waiting for it. Yet the largest search available produced no confirmed wreck, no final message, and no explanation. Investigators then turned from rescue to reconstruction. Without the ship, they had to study its history, its modifications, its openings, its drainage, its crew arrangement, the expected route, and the weather. Their task was not to invent a dramatic final scene. It was to determine which known conditions could cause a vessel like Holo Holo to disappear without time for a warning. The National Transportation Safety Board reached a direct conclusion. It determined that the probable cause was the operation of Holo Holo in an unseaworthy condition, directed by the owner and accepted by the Research Corporation of the University of Hawaii. The wording was important. The board did not treat the loss as an unknowable act of nature alone. It identified physical and operational weaknesses that made the vessel less able to survive the conditions it likely encountered. One major concern was a 2-foot by 4-foot opening in the after main deck. Another was a large opening in the bulkhead of the aftermost deckhouse. According to the NTSB, these openings could allow water to enter the vessel rapidly. Below deck, penetrations through bulkheads were not sealed in a way that would stop water from moving from one space to another. That created a risk of progressive flooding. The vessel also had inadequate freeing ports. Freeing ports allow water that comes onto an exposed deck to drain back overboard. If drainage is too limited, water can remain trapped on deck. That water adds weight high on the vessel and changes its stability. A ship does not need to be pierced below the waterline to become endangered. Enough water entering from above, remaining on deck, and moving into internal spaces can reduce its ability to return upright after rolling. The NTSB also cited an insufficient number of qualified operating personnel to maintain a continuous 24-hour navigation watch. That finding did not prove who was at the controls at any specific moment. It showed that the voyage's staffing arrangement reduced the margin for fatigue, weather monitoring, radio communication, and immediate response. The Coast Guard investigation developed a closely related scenario. Based on reconstructed conditions, The Marine Board concluded that Holo Holo most probably encountered seas high and frequent enough to flood the forecastle. With drainage described as grossly inadequate, water could accumulate until the vessel lost stability and capsized. The Coast Guard identified the lack of watertight integrity as a probable contributing cause because it could permit flooding to spread internally. Weather estimates helped explain why those deficiencies mattered. At the probable time and place of the loss, the Coast Guard estimated significant wave heights of approximately 14 to 17.5 feet, higher than predicted. Significant wave height is an average measure, not the height of every wave. Investigators calculated that occasional waves could have reached roughly 22 to 28 feet. Those figures do not provide a photograph of the final minutes. They describe an environment in which repeated water over the bow or deck could exploit every weak opening and every drainage problem. A vessel might appear functional in calm water and still possess vulnerabilities that become critical when waves arrive faster than water can escape. The lack of a distress call fits a rapid loss of stability, but it does not prove one exact sequence. Investigators considered that a sudden capsize could leave little time to recognize the full danger, reach the radio, state a position, and deploy life-saving equipment. The NTSB said the absence of a distress signal or radio message might have contributed to the loss of life. It also meant rescuers began without a precise location. The official reports were careful about certainty. The Coast Guard acknowledged that the circumstances could not be determined completely and that other scenarios were possible. No investigator had the hull to examine. There was no recovered logbook describing the last hours. There were no eyewitnesses. The probable cause findings were evidence-based reconstructions, not a claim that every movement of the vessel was known. Then, 1 year after Holo Holo disappeared, the ocean returned a signal. On December 9, 1979, the NOAA ship Townsend Cromwell transmitted a triggering signal while operating in the region. An acoustic response came back from the seafloor. The following day, specialists identified the responses as coming from underwater acoustic devices known to have been carried aboard Holo Holo. The location was recorded near 20 degrees 6 minutes north and 156 degrees 28 minutes west. A federal court later summarized the significance of the discovery. The signal came from a depth of about 7,200 feet in the Alenuihaha Channel, around 28 miles south of Maui. The site was about 17 nautical miles northwest of Holo Holo's intended research area. The NTSB concluded that the vessel had sunk where the transponder replies originated. The discovery provided a probable resting place, but it created another question. Why was the vessel northwest of the research site? The location was not necessarily evidence of a mysterious diversion. A ship traveling from Honolulu toward Hawaii Island would pass through the broader region before reaching Kawaihae, and the exact route could be affected by weather, navigation, or operational decisions. With no surviving record from the vessel, investigators could not establish its final course with precision. The acoustic reply was both an answer and a boundary. It supported the conclusion that Holo Holo had gone down in deep water. It did not reveal the orientation of the wreck, the condition of the hull, or the sequence in which water entered. The instruments could identify themselves. They could not tell investigators what the people aboard had seen. The loss continued into courtrooms. Families brought wrongful death actions alleging failures in design, alteration, maintenance, communications, crewing, safety equipment, and the timing of notification. The litigation involved the University of Hawaii, the Research Corporation of the University of Hawaii, the University of California, the state of Hawaii, and individuals connected to the vessel. The legal decisions preserved a detailed institutional record of the voyage, even though they could not recover the missing ship. The tragedy also left a lasting mark on ocean science in Hawaii. The University of Hawaii lost Gary Niemeyer, Michael Allen, and Robert Harvey. Memorial plantings and a plaque were established near the Hawaii Institute of Geophysics building, and the garden was later restored and rededicated. Colleagues described the loss as a major setback for the program and for the broader research community. Other institutions carried their own memories. Later scientific work by NOAA researchers was dedicated to Robert Charnell and Patrick Laird, who were also lost aboard Holo Holo. These memorials shift the story away from machinery alone. The casualty was not simply a failed vessel or an engineering lesson. It removed scientists, technicians, crew members, spouses, parents, colleagues, and friends from lives that were still in progress. There is a temptation to describe an unresolved maritime loss as a supernatural mystery. Holo Holo does not need that treatment. Its documented facts are more unsettling than an invented legend. A scheduled vessel left a familiar harbor, passed a world-famous shoreline. It entered rough inter-island water with serious weaknesses that had not prevented it from sailing. Then the normal chain of communication ended. The most evidence-based explanation is not that the ship vanished without cause. It is that environmental forces exposed vulnerabilities already present in the vessel. Water likely accumulated where it could not drain quickly enough, entered through openings, spread through spaces lacking watertight separation, and reduced stability until recovery was no longer possible. That is the combined direction of the federal investigations, even though the exact final sequence remains unobserved. The case also demonstrates why maritime safety is built from layers. Weather forecasts matter, but so do conservative decisions when forecasts are uncertain. Hull openings matter. Watertight boundaries matter. Deck drainage matters. A qualified watch matters. Regular radio contact and emergency position equipment matter. Any single protection can fail. The purpose of multiple protections is to prevent one failure from becoming irreversible. In 1978, Holo Holo sailed under circumstances that allowed serious deficiencies to remain hidden from a complete inspection regime. The NTSB noted that its status and use had helped leave its actual condition insufficiently examined. The disaster became part of a broader record used in research vessel safety discussions, where the lesson is not limited to one ship. Conversions and modifications can change how water moves through a vessel and how it behaves in heavy seas. A structure that looks practical for scientific equipment may weaken the boundaries that keep the ocean outside. What remains unknown is deeply human. Nobody can say when the people aboard first realized the voyage was in danger. Nobody can confirm whether there was a mechanical warning, an unexpected wave, a course change, or an attempt to send a message. The official record ends before those moments and resumes with an overdue vessel, a vast search, and a signal from the seabed 1 year later. That gap is why Holo Holo remains a mystery, but it is a specific kind of mystery. It is not a blank space where any theory is equally valid. The evidence narrows the possibilities. The location of the acoustic instruments, the reconstructed seas, the drainage problems, the open pathways for flooding, and the stability analysis all point toward a rapid marine casualty in severe conditions. The uncertainty lies inside that conclusion. Investigators can explain how the vessel was vulnerable and identify the most probable mechanism of loss. They cannot replay the final minutes. They cannot recover the words that were never transmitted. They cannot give the families a complete account of what each person experienced or exactly when the ship passed the point from danger to disaster. Today, the most enduring evidence is divided between two places. On land, a memorial at the University of Hawaii preserves the names and work of colleagues who never returned. At sea, far below the channel between Maui and Hawaii, acoustic instruments once answered a coded call from the darkness. The reply confirmed that something from Holo Holo had reached the bottom. It also marked the limit of what technology could recover. The ocean returned a position, but not the final story.